This is the second part of lecture 6, that is effluent treatment, and in this part I'll talk about the physical, chemical and biological treatment methods. Okay, so let's start with physical treatment. Well, so we already know from the last part that physical treatment methods, I mean, they are used in different stages, like during the primary treatment, tertiary treatment, or the slash conditioning. Okay, so anyway, so the physical processes which are installed for primary effluent treatment, they may include the following stages. Okay, so number one, coarse screens. Okay, so this is done to remove larger suspended and floating matter. Okay, so however, I mean, this I mean is unlikely for, I mean, coarse screens are usually unlikely required for fermentation effluents, because fermentation effluents usually don't contain large suspended or floating matter. Okay, rather the fermented effluents, they contain fine uh, particles. So that's why fine screenings, I mean not the coarse screenings. Coarse screenings are used to remove large particles. Okay, but as the fermented effluent, they may contain fine particles, so fine screens is sometimes required. Even sometimes micro screens may be required. Okay, then communitors, they are actually grinders. Okay, so communitors are used to are used to reduce particle size, to either increase the rate of BOD removal or prevent blockage in subsequent unit operations. I mean, if the particle size are very too big, they may block the subsequent unit operations. I mean, subsequent operations of the treatment process. Okay, then grit removal. Okay, grit removal is used to remove the sands, grit, etc. Okay, and it is necessary to prevent damage to plant in later processes. Okay, and it is done by different, I mean, the grit can be removed by different ways, like using horizontal flow chambers or constant velocity channels, aerated chambers and vortex chambers, etc. Okay, however, grit removal is highly unlikely to be required for fermentation effluents. Okay, so fermentation effluents, they don't contain sand or grits. Okay, sand or grits. Okay, then flow equalization. Okay, so flow equalization is necessary for temporal storage of effluent streams to maintain constant flow or BOD loadings to later operations. Okay, then sedimentation tanks for the removal of finer suspended matter. I mean, if the effluent contained fine suspended matters, uh, sometimes they are left for defined amount of time, say for example for several hours. So during this time, the fine suspended matters, they get sedimented, I mean they settle down in the bottom. Okay, so thus they can be removed. Okay, and time to time this sedimented portions, they are removed. Okay, and this process, I mean the sedimentation of finer suspended matters, can be achieved by using tanks. Okay, and usually these are circular or rectangular continuous flow tanks operating at a retention times of 6 to 15 hours. Okay, and this retention time should not be less than uh, 2 hours. Okay, and also there should be facility to continuously remove the sediment, that is the settled slash. Okay, and the sedimentation tanks can remove 70% of the incoming suspended solids, a quite efficient process. Okay, and depending on the nature of the waste, up to 40% of its BOD load. It's actually big. Okay, and they can operate it with or without prior chemical coagulation and flocculation. I mean, sometimes first coagulation or flocculation is done, then that effluent is flow through the sedimentation tank, or sometimes before doing the coagulation or flocculation, effluent can be flow through the sedimentation tanks. Okay. Okay, I mean, although these stages are for primary effluent treatment, but the sedimentation tanks, I mean, this similar kind of treatments are also conducted after secondary treatment of the effluent. Okay, that means these tanks can be used are used both during the primary treatment and also after the secondary treatment. Okay, then flotation. Okay, so flotation is used to separate solid particles from the liquid phase by the surface introduction of fine air bubbles. Okay, so these bubbles, they adhere to the solid particles and rise to the surface where they can be removed. Okay, I mean, say the effluent, it contains solid particles, so if fine air bubbles are flow through them, then this when these bubbles go through this liquid, the solid particles, they get attached with these air bubbles and they float in the surface of the liquid. Okay, so then they can be removed from the surfaces. Okay, then uh, aeration. Aeration is used in the removal of volatile organic compounds. Okay, however, aeration may create off gases. Aeration may produce off gases. So if off gases are produced, it itself require another different treatment strategies. And one strategy can be use of granular activated carbon or thermal oxidation to remove the off gases produced by aeration. Okay. Okay, and another way, thermal use of thermal technology, that is use of combustion. Okay, so combustion is usually used when the waste contain hazardous materials. Okay, so hazardous materials produced from antibiotic fermentation. I mean, during the antibiotic fermentation, different hazardous materials can be produced. Okay, which will be end up in the waste. So this kind of hazardous waste, they can be treat, treated by combustion. Okay, by burning them. Okay, so this was about the physical treatment. Then chemical treatment. Okay, uh, coagulation and or flocculation to remove fine suspended materials. Okay, so chemical treatments are usually done as coagulant or flocculant. Okay, for example, ferrous or ferric sulfate, aluminum sulfate, calcium hydroxide. Calcium hydroxide means lime. Okay, and uh, polyelectrolytes. These are some chemical agents which are often used as chemical coagulants. Okay, that means these chemicals can be used to do the chemical treatment as using as chemical coagulants. Okay, so then biological treatment. Okay, well, most organic waste, they can be treated by biological way, because most organic wastes, they can be digested or degraded by using cells like microbial cells. Okay, and this process is conducted both aerobically and or anaerobically. Well, we know that there are aerobic microorganisms and anaerobic microorganisms. Okay, so if we want to use aerobic microorganisms to degrade the organic waste, we need to do the process aerobically. And if we use anaerobic microorganisms to degrade the waste, organic waste, then we have to do the process anaerobically. Okay, and there are different ways or methods to do the aerobic and anaerobic processes. For example, aerobic process, they can be done by trickling filters, rotating disc contactors, activated sludge processes, and some modified version. Okay, and anaerobic processes, they are done by like digestion, filtration, and sludge blankets are used both in the treatment of specific wastewaters and in sludge condition. Okay, so actually, the in the waste treatment, both aerobic and anaerobic processes are used. Okay, and usually all the treatment process, okay, they have several stages which is mentioned in this slide, like the primary, secondary, tertiary, and the finally slash conditioning. Okay, and in different stages different methods are used, or combination of methods, like for primary treatment both physical and chemical methods are used. Okay, for tertiary treatment both, I mean, all the physical, I mean, for in tertiary treatment, physical, chemical, biological, all of these methods are used. Okay, so whether, I mean, all these methods will be used, or like only one methods will be used, or two methods will be used, it depends on the waste. Okay, okay, so that's all about the effluent treatment. And again, this lecture, I mean, all the information uh, of this lecture was taken from this book, Principle of Fermentation Technology, is by Stanberry, third edition, and chapter 11. Okay, so this lecture is actually just a summary of the effluent treatment. Okay, so I will again suggest you to check the book. Okay, because effluent treatment is an important thing, not only because we need to treat the effluent for the environmental safety. It is also important because effluent treatment plant, okay, it is a it is a place where we biologists can work. Okay, so I mean, if you can, I mean, if you can excel your expertise in effluent treatment, definitely you may have a better chance, okay, to work in this area. Okay, and effluent treatment is actually getting, I mean, is getting more important. Okay, especially in the developing countries. I mean, in the developed countries, effluent treatment is already a must required thing. Okay, so all the industry, they must have proper effluent treatment plants. But in country like us, these things yet have not been started fully. I mean, still many industries, they don't have proper effluent treatment plants. But as time will go, more industry, I mean, by the regulation, more and the law, more industry will have to establish the effluent treatment plant. Okay, okay, that's all. Thank you for your patience.